Hello, I'm Eli Thummel from the Killer Bees, and today we're going to show you how to convert a normal wood cutting bandsaw to use for metal cutting for robotics teams. This is an essential skill for robotics teams to be able to know. Very easy, and it's very useful. Most of these wood cutting saws all act the same, but unfortunately they run generally too fast for a robotics team to be able to use for cutting metal. You go through blades too fast, and it's just easier to slow them down. Saws like this Jet 14-inch are really easy to get off of third-party sites like Craigslist and other personal sites, and they can be really easily converted to great saws, really great saws for the money, and great saws for use for the robotics teams. So today, we're going to show you how to convert this Jet bandsaw using just a few simple parts and a few simple skills to a great saw for your robotics team. Like I said, here we have a 14-inch Jet bandsaw. It's great. We got this for $400 off of Craigslist. It's a great deal. It has a nice slider mechanism here. It has a 6-inch riser lift, a work light, and as you can see, it's been very gently used. It's in great shape with these roller mechanisms for upgrades. And overall, it's just a really solid build saw and a really great saw to start off with. A saw like this on the new market could cost anywhere $800, $1,000, easily double of what you would pay for a great saw like this, and it's going to be a great conversion of what we're going to do today. So when working with one of these saws, they pretty much all work the same. They're working on a series of pulleys with a V belt right here, a pulley in the top, and a pulley at the AC motor at the bottom. This AC motor is basically just powering this belt to the pulley to power the saw. So this is really easily converted into a different speed by just changing the size of these pulleys. And that's what we're going to do today, by adding another pulley in here with the belt to change the size and therefore to change the speed. So it's pretty easy. This method applies to every single general saw, bandsaw like this, because they all pretty much work the same. Just an AC motor powering a pulley and a belt. So here are the parts that we're going to need. It's about $100 of parts, but pretty simple. We have a couple of aluminum extrusions here. We have a 2-inch and a 6-inch pulley for a 3-to-1 reduction. We have a keyed shaft for the pulleys and the keys for the shaft. 2 brand new V-belts for our bandsaw. 2 5-inch bearings for the pulleys. A brand new metal cutting saw. And a few 3/8-inch hardware here, bolts, washers, and nuts. These hardware is pretty simple, pretty self-explanatory, and can apply to pretty much every bandsaw. The sizes and lengths that we use here will differ a little bit from what you might use at your conversion, but a full parts list for what we're using today will be listed in the description. Also, as far as tools go, you can see just a few simple wrenches and sockets, maybe an Allen key or a Phillips head screwdriver or a flathead screwdriver to use here today. Overall, these are pretty simple parts that you can get for about $100 that apply generally to most conversions, and a few simple hand tools will get you on your way for this conversion. So the first step in this conversion is to take off this pulley cover, loosen up the motor to be able to get the belt off. So we're going to do that now. Sometimes these things can be a little finicky, but a few simple hand tools and patience will get you a long way. These saws typically run somewhere around 3,000 feet per second. So our conversion doing here today, we want to drop it down to somewhere around 800 to 1,000 feet per second, which is much more suitable for the work that we'll be doing in robotics. And just with a few screws, this pulley cover can come off. Like you said, it's a little finicky in there with the bolts, but it's not too bad if you have a little patience. Now, there are a couple bolts down here for the motor, so we're going to loosen those up so we can drop it down. There we go. It looks like we got our motor loose. So now we can just prop it up and get this belt off. That's the first step to converting this. So you can expose this pulley, loosen up the motor, get the belt off, and get ready for the next step. So we're going to mock up our assembly here. We have a bearing, a shaft, and a few other parts that we'll get to. Put our shaft in the bearing. We have a keyway from a bag of keyways right here. We had to grind these keys down a little bit to fit the width of these pulleys, but that's okay. Just a few simple hand tools, a little belt sander, a grinder, or even a few files. So that fits up nicely there. Then we have our second key. Then we have our other pulley. Then we have our other bearing. So you can see we have a pretty nice assembly here. And we can go in with a few Allen keys. One for the bearing here. And one for these pulleys that we have. And that way we can tighten everything up so it all spins nice and well with the shaft, so we can move to the next step of mounting this on our saw. So we've plotted out our points, measured and center punched for our holes that we're going to drill, and now we're just going to drill them on this old drill press here to be able to mount up our hardware. So now we got our pilot holes drilled for both of our pieces here, and we're going up to a 3/8 hole in these, but we're doing it in steps. So we started with a 5/32, now we're going to a 1/4 inch hole, and then we'll step up to our 3/8 inch hole. So we have our bar drilled out to 3/8 inch, so it fits in here. But now we have to widen up these holes, and so we're going to step them up from a 5/16, then to a 3/8. So we're going to do that now. Next is a 3/8 inch drill bit. Now that we have those bolts widened out, we can mount this up with our hardware. We have the mount our bearing block. So now we're just going to attach up our hardware, mount to these bars so we can throw it in the saw. Now that we have our reduction assembly built up, we need to know the center distance of these holes. You can see it's about 3 3/4. Just to check that, here and here. So overall we have about 3 3/4 center to center, about 5 inches for the total width, and so we can use that measurement to mock up our second set of holes to mount it on the saw. Okay, so we laid out where our two new holes are going to be drilled, and right there and there. And so now we're just gonna do the same thing as drilling in our stock. Just step up from 5/32, quarter, and then up to our 3/8 inch holes. There we go. So now we can step up that to a 1/4 inch and the 3/8 inch so we can mount our hardware. Okay, so I have the assembly over here to my left, and we're gonna install this rear bar. We drilled these 2 new holes to clearance for the bearing bolts, and so now we're gonna mock this up. An important thing to note is before you install this assembly, slide your belts on, because otherwise you won't be able to get them off. Very important thing to do. Okay, so now that we have this whole assembly mounted, we can go back through, tighten all the bolts, cinch everything up, and get ready to throw in our pulleys so that we can mock everything up here and connect it all. So then we can have a working reductive bandsaw. Okay, so it took a little fiddling and a little bit of wrenching, but we finally got everything mounted up, everything tightened up. We decided to add a washer or 2 underneath the bearing, in between this aluminum extrusion and the bearing down there, so we could get a nice tight belt feel. And that'll change depending on your configuration, so results may vary for you on how tight or loose or what you have to shim down here. Anyways, for us, this all looks good. All of our bolts are tightened up. We have washers in all the places we need to. All the nuts are good on the bottom side, and so we can move on to mounting our bottom pulley and belt. Okay, so we have our assembly here, and we're gonna see if we can mount this bottom pulley. Now this motor is on sliders, so the slots in this bottom bracket here, and that's pretty common for most of these AC motors down here. And so first I'm gonna see if I can mount this bottom belt on the bottom pulley, then try to lift the motor with the belt, bring the belt around, make sure I got it on both pulleys, then slowly try to roll it on. Oh, I'm off the belt on the bottom there. Let's see. Lift the motor, there you go. Might take a little fiddling like everything else, but there we got that pulley and the belt all good. So I can see already that we're gonna have to undo this Allen grub screw right here to bring this pulley out so that this belt is parallel with the belt up here. And then after that, we're just gonna tighten the motor mount bolts, make sure this belt is tight, and then we'll be done. Okay, so we have everything set up here, everything tightened up, both of our belts on, all of our pulleys mounted, our motor tightened up and dropped down to the correct height. And so we're going to try and do a test run. Turn it on here. Looks like everything is running relatively nicely. You can see the reduction here. Running up. And if you come around to the other side here, we can see RPM. So if we open this up, a little test strip here with a tachometer, and it should be about 250. We're reading 220, 225, 227 right there, if you can see that. And so that's about within the range of what the math says of the reduction should be. So that sounds about right. Should be really nice for a conversion like this and really nice for cutting aluminum. So a couple last steps here to button up this back end of the machine. We want to put the pulley guard back on because we care about safety and want to make sure everything is buttoned back up. So I already have one bolt in there, so I'm going to throw the second bolt in. Yeah, line it up. There we go. And since we use some of the mounting hardware of the back part of the mounting bolts for the back part of the pulley guard for our modification, we made this little plate that fits in back here and mounts to the cast iron work of the machine. And with 2 simple bolts back here, you can see that it'll clamp in back part of the pulley guard to the machine just like that. So here we are putting the last few bolts on the back flange for this pulley cover here. And this is cinching in this back flange here. It's just a little piece of 1/8 inch aluminum to help us out. This will all be minusculely tightened up and adjusted, but with just a few simple modifications, you can see that we retain a back pulley cover so that all that can tighten back up so we have a safe working machine. Okay, so as one of the last steps of our conversion for this cutting saw, we're going to change the blade, and this is how you do that. First of all, we're going to take off the blade guard here, just 2 bolts. Set that to the side. It's a helpful tip if you can to put your bolts back in the place where they go so you don't lose them. There we go. Next, we're going to drop this top down as far as we can. As you can see, this loosens up the blade, so we can just slide it out here, go around the blade guard, and there's this slot in the base plate that we can just slide out. We can set this to the side. And then grab a brand new metal cutting blade. This is a good quality 14 tooth per inch blade, and it'll be a great fit for this saw. Unsheathing it from the plastic wrap here. Of course, being very careful not to cut yourself. Then we can do the exact reverse of what we just did to get that other blade on. Next, just check to make sure everything's centered, everything's not rubbing where it wants to be. You can tighten up this top. That should work out. Then we can put our blade guard back on. It's all good. Make sure that the blade guard is not touching the blade, so you don't have any interference. Close that, and then put your little plate back on here. There you go. Now, conversion is done, and you have a fully working metal bandsaw that you can use for your robotics team. Let's test the piece. It cut great using all safety precautions. Make sure you're safe with this saw. It still is a saw, and it's a beautiful cutting bandsaw, greatly adapted for this metalworking that we do, and it will you can use it in your robotics team. It's an amazing asset, really easy to come by, really easy to adapt. Just in a few hours, one day, and you're left with a great, very, very valuable tool. Thank you. We love the adaptability of a mobile base. This allows us a little bit of flexibility within our shop, and so we cut down, modified slightly this one mobile base the other day. So we're going to use it, mount it on this tool, so we can use it in our shop. So we adjusted the feet on our mobile base so that it sits nice and flat and stably so you can use it. And with the flip of the lever, you can move it around for portability. This is the final step of our conversion here on this one-day build with the Killer Bees Robotics team. This saw will be a great saw, a great asset to your team, and will last you for years to come. Thank you.